Module 4, Lesson 7. In Module 4, Lesson 7, we're going to talk about how to solve one-step equations using addition or subtraction. Let's start out with our academic vocabulary. We'll drill into our glossary in VMath, and we're going to look up the word equation. For the letter E, we're going to pull up equation. A mathematical sentence formed by placing an equal sign between two expressions. That is an equation. What is a solution? What is a solution? Let's look up solution. A solution, a number that when substituted for a variable in an equation results in a true statement. So a solution is a number that when substituted for a variable in an equation results in a true statement. So let's get started. What is the value of 30 minus s when s equals 21? This is simply substitution, which we have done in the past. So we are substituting 21 for everywhere there is an s. So 30 minus s is 30 minus 21. Now 30 minus 21 is, quite simply, 9. Next example. b plus 10 when b equals negative 8. Here we are substituting negative 8 for b in the equation. So b plus 10 is the same thing as negative 8 because we're substituting the negative 8 for the b, negative 8 plus 10. Here we are adding unlike signs. What do we know about adding unlike signs? When we add unlike signs, we take the smaller from the larger, or more specifically, we take the absolute value of 10, which is 10. We take the absolute value of 8, which is 8. So now we take the smaller from the larger. So we take 10 minus 8, which is 2. And we keep the sign of the larger number, which in this case would be 10. And it is positive. Therefore, our answer is positive 2, or just 2. Example C. 3 plus n when n equals negative 12. 3 plus n equals 3 plus, and we substitute negative 12 for n here. Once again, we are adding unlike signs. When we add unlike signs, we once again take the absolute values of both numerals, which is 12 and 3 respectively, 3 and 12 respectively. Then we take the smaller from the larger, so it is 12 minus 3. 12 minus 3 is 9. Which one had the larger absolute value? That was negative 12, therefore our sign remains negative. So our answer is negative 9. Negative 9. Now let's look at problem number 2. An equation is a mathematical sentence formed by placing an equal sign between two expressions, as we discussed earlier. The equation in problem 2 contains a variable. The goal is to find a variable for s that makes the equation a true statement. Such a number is called the solution of the equation. To solve an equation with a variable, get the variable by itself on one side of the equation. To solve s plus 7 equals 12, we first must get s by itself. Look at the first diagram on the right of problem 2. It is a diagram of a balanced scale with the variable s and 7 blocks on the left side and 12 blocks on the right side. What expression represents the left side of the scale? S plus 7. You have the variable s plus 7 blocks. 7 ones blocks, so it's s plus 7. What number represents the right side of the scale? 12. You have 12 ones blocks on the right side of the scale. To get s by itself on the left side, how many blocks will need to be removed? 7 blocks. If 7 blocks are removed from the left side, how many blocks will have to be removed from the right side to keep the scale balanced? Yes, once again it is 7. The second diagram shows a balanced scale after 7 blocks have been removed from both sides. What equation is represented in the second diagram? S equals 5. In the equation, s plus 7 equals 12. If 7 is subtracted from the left side of the equation, s will be by itself. Subtraction is used to get s by itself because subtraction is the opposite or inverse operation of addition, and in the equation, 7 is added to the variable. What is s plus 7 minus 7? S plus 7 minus 7, you're left with just s. Unless a zero pair is being added to one side, whatever is done to the other side is done. Whatever's done to one side of the equation, must be done to the other side of the equation to maintain equality. So because 7 was subtracted from the left side of the equation, 7 also must be subtracted from the right side of the equation. What is 12 minus 7? 5. The solution of the equation is s equals 5. S equals 5. So now we can check this solution. So to check the solution of an equation, we substitute the solution for the variable in the original equation. If both sides of the equation are equal, then the solution is correct. Check the solution of the equation in problem 2. The solution is s equals 5. So substitute 5 for s in the original equation. So we'll substitute 5 where the s would have been in the original equation here. Okay. Now, what is 5 plus 7? 5 plus 7 is 12. Does 12 equal 12? It does indeed. Therefore, our solution is correct. Notice there's a check mark above the equal sign to indicate that both sides are indeed equal. Now let's look at problem number 3. Negative 6 equals r minus 4. Negative 6 equals r minus 4. Where is the variable? The variable in this equation is on the right side. So to solve negative 6 equals r minus 4, we need to get r by itself. The opposite operation of subtraction is addition. So add 4 to both sides of the equation. So we'll add 4 here, and we will add 4 here. Now, what is r minus 4 plus 4? It is simply r, because 4 minus 4 is 0. So you're left with r on the right-hand side of the equation. What is negative 6 plus 4? Once again, we're adding unlike signs. Therefore, we take the absolute values of both. We take the smaller absolute value from the larger. So we have 6 minus 4. And 6 minus 4 is 2. And the one with the larger absolute value was negative. So therefore, our solution is negative 2. So we have negative 2 equals r. We can check this solution of the equation in problem 3. To evaluate, what do? We plug in negative 2 everywhere we see an r. So in this case, it's negative 6 is negative 2 minus 4. What do we know about subtraction? We change subtraction to addition of the opposite. We haven't changed the negative 2, it stays the same. We change subtraction to addition. The opposite of positive 4 is negative 4. So therefore, negative 2 plus negative 4. We're adding like signs, so we add them together. 2 plus 4 is 6. And the sign is negative. Therefore, our solution is indeed negative 6. Are we correct? Negative 6 indeed equals negative 6. Now let's take a look down at the building the concept. Look at the equation modeled with the algebra tiles. What is the equation? We have one green bar representing x, and then we have plus 6 ones tiles. So our equation looks like this. This is all on the left-hand side of the equation. We have one tile representing x, or our variable. We have plus, which is our operation. And then we have 6 one tiles, so it is x plus 6. Equals, and on the right-hand side of our equation we have, you see 1, 2, 3, 4, 5, 6, 7, 8 ones tiles. So x plus 6 equals 8. How many ones tiles must be removed from each side? Well, what do we have to do? We have to get x by itself, so how many ones tiles are on the left side of the equation with the x? You have 1, 2, 3, 4, 5, 6. So we have to remove 6 from the left-hand side of the equation. And if we remove 6 from the left side, we also have to remove 6 from the right side. So how many remain? Oh, let's remove those tiles first. We have to remove 6. 1, 2, 3, 4, 5, 6. So now we have removed 6 from the left side. And how many do we have remaining? There's 0 left on the left side. What remains on the right side? After we remove 6, we have 1, 2 tiles, 2 ones tiles remaining. So our solution is what? X equals 2. X equals 2. Okay, let's move on to the try it together. Let's take a look at problem number 4. What is the variable in problem 4? The variable in problem 4 is the letter K. The letter K. How is the equation K plus negative 3 equals 7 solved? We have to get K by itself, as we've done in the previous problems. And how do we get K by itself? What are we doing to K? What operation are we using in this equation? We are using addition. So the opposite of addition is subtraction. Therefore, we must subtract negative 3 from both sides of the equation. So we subtract negative 3 on the left. Negative 3 on the left. And then we also must subtract negative 3 on the right. This keeps our equation balanced. So negative 3 minus negative 3, negative 3 minus a negative 3, we change subtraction to addition of the opposite, it's going to become negative 3 plus 3. So that's going to leave nothing but K on the left-hand side, because negative 3 plus 3 is indeed 0. Now, on the right-hand side of the equation, we have 7 minus negative 3. Once again, we're changing subtraction to addition of the opposite. I'll write this where you can see what it looks like. We have 7, okay, plus the opposite of negative 3 is indeed 3. So now 7 plus 3 equals what? 10. Okay, so 7 plus 3 equals 10. Therefore, K equals 10. How can we check this? We check this the same way we've done the ones in the past. We substitute 10, positive 10, for K in our equation. So therefore, 10 plus negative 3, does it equal 7? Well, once again, we have opposite signs, or different signs. So when we're adding unlike signs, we subtract the smaller from the larger. So in this case, we take 10, and we subtract 3, and we keep the sign of the larger, and the sign of 10 is positive. Therefore, our answer is indeed 7 equals 7. Therefore, our equation does indeed check out. Oh, let me clear these annotations first. And we will move down. If I can get it to grab here, just 1 second. Let's go ahead down here and look at problem number 5. In problem number 5, we have 10 and 2/10 equals 6 and 1800ths plus S. This one looks like it's a little more complicated. It's just dealing with decimals, which means you may want to get your calculator out if you haven't done so already. So we have 10 and 2/10 equals 6 and 1800ths plus S. Same rule applies. Even though S is on the right-hand side of our equation, we still need to get it isolated or get it by itself. So what we need to do in this case is we are currently adding 6 and 1800ths to S. So the opposite of addition is subtraction, so we're going to subtract. And what do we need to subtract? We are going to subtract 6 and 1800ths. And whatever we do to one side of the equation, to keep it balanced, we must also do it to the other side. So we are also going to subtract 6 and 1800ths from the left-hand side of the equation. If you don't have your calculators out and you want to do it manually, let's see if I can do this rather neatly here. I'll sure try. We have 10 and 2/10, which is the same as 10 and 20 hundredths. We can add a 0 without changing the value. And we are going to subtract 6 and 18 hundredths. Now, we cannot take 8 from 0, so we must borrow, make this a 1. And then we have 10 minus 8 is 2. We have 1 minus 1 is 0. We've lined our decimal places up, so we bring them straight down. And 10 minus 6 is 4. That is a nasty looking 4, but it is, whoops, it is indeed a 4. So therefore, whoops, keep drawing everywhere now. Therefore, our answer is 4 and 2/100ths. S equals 4 and 2/100ths. S does indeed equal 4 and 2/100ths. Now, can we check this? Sure we can. 10 and 10 and 2/10 equals 6 and 1800ths plus S. We substitute 4 4 and 2/100ths for S. So 4 and 2/100ths. So now it says, does 10 and 2/10 equal 6 and 1800ths plus 4 and 2/100ths? Well, if we don't have our calculators, once again, we can do this manually, and we can go 6, and I'll try not to make such a mess this time, and 1800ths plus 4 and 2/100ths. 8 plus 2 is 10. We put down the 0 and we carry the 1. 1 plus 1 is 2. Bring down the decimal. And 6 plus 4 is 10. So indeed, 10.2 does equal 10.2, or 10 and 2/10 does indeed equal 10 and 2/10. Number 6. Let's have a look. Y minus 29 equals 18. Well, once again, we have to get y isolated or by itself on one side of the equation. And in this case, we are subtracting 29 from y. So the opposite of subtraction is addition. So we have to add 29 to the left-hand side of the equation. If we add 29 to the left-hand side of the equation, once again, we must add it to the right-hand side of the equation. Therefore, negative 29 plus 29, it goes away, or it cancels itself out, becomes 0. So we bring down the y. So now y equals 18 plus 29. Well, 8 plus 9 is 17, and we carry our 1, so our answer is 47. 47. And we can once again easily check this by substituting 47 wherever we find a y in our equation. So therefore, y minus 29 equals 18 will be 47 minus 29 equals 18. Once again, if you don't have your calculator and you want to do it manually, we do 47 minus 29. We cannot take 9 from 7, so we borrow. We now have 3/10. We have 17 ones. So 17 ones minus 9 ones is 8. 3/10 minus 2/10 is 1. Therefore, we do indeed have 18 equals 18. Pretty simple stuff. Simple substitution for the most part. Let's clear those annotations again. Clear all that out. And we will scroll further down here, and we will look at the work on your own. We solve one-step equations using addition and subtraction. If we're using symbols, the equation looks like this. Y minus 7 equals 26. Or y minus 7 plus 7 equals 26 plus 7. Or y equals 33. So what have you done? You get the variable by itself on one side of the equation. If the equation has a variable plus a number, then subtract that number from both sides of the equation. If the equation has a variable minus a number, then add that number to both sides of the equations. Then you can check it. To check, substitute the solution for the variable. If both sides of the equation are equal, then your solution is indeed correct. What I want you guys to do now is I want you to start working on independently in VMath, in your student ebooks. I want you to work on the skill building new and review. Of course, make sure you submit pages 23 and 24 with all of the stuff you have keyed in there. I want you to solve each equation, then check the solution for the skill building new and review. So I'd like you to complete problems 7 through 15 on your own. So go ahead and pause this video or stop this video. I would just pause it for now. And then you can come back and we will walk through the solutions. I'll walk through the answers, and if you have any questions, you can email me with those questions or put it up on It's Learning there, and we will go over any questions that you might have remotely. So go ahead and work on the skill building new and review. And pause now and work on those. Okay, let's continue looking at the skill building new and review. A minus 20 equals 50. Number 7, A minus 20 equals 50. We have to get A by itself on one side of the equation. In order to do that, we need to add 20 to both sides of the equation. So A minus 20 plus 20 will simply leave A on the left-hand side of your equation. And then 50 plus 20 will equal 70. So your answer should be, your solution should be A equals 70. A equals 70. Number 8, B plus negative 17 equals negative 30. You're adding negative 17 to B, so therefore we must subtract it. So you will have B plus negative 17 minus negative 17. So you'll be left with B on the left-hand side of your equation. And then you'll have negative 30 minus a negative 17. Minus a negative 17, we change subtraction to addition of the opposite. You'll have negative 30 plus. You'll have negative 30 plus 17. You'll have negative 30 plus 17. Therefore, B will equal negative 13.